Okay, welcome back. So today is Friday, 28th of January 2022. We are in week 3 and we're in lecture 6. So as I mentioned, I will do any Q&A if you have any. Just type in the chat. If not, I will begin to do some past year's exam questions. So there's no new materials here. I'll just go through some past year's exam questions, and then you can see the style and format. I've personally set the last 5 years, I think, exam questions, question 1 and 2. Okay, so again, for this year, I will also set the question 1 and 2. All right, so if you look at the style, then that should be what you're looking for. All right, so what I'm going to do is this. In November, December 2015, so that's about 7 years ago, and I'm going to do question 1A. All right. And you realize that for sickness, it will typically happen in question 1. Sometimes question 2, but typically question 1. So I'll write the questions down for you, and then we can begin. So a continuous time signal, x of t, and then I now give you the equation of the signal to sine 40 pi t plus 3 cosine 60 pi t is sampled, right? And then the question is very interesting. It says find x1 of n, x2 of n. What is x1 of n? Using fs, sampling equals to 100. X2 of n, using sampling equals to 40. Okay, that's the question. And then comment on x2 of n for xt. Okay, so this is a 6 marks question. So let's begin. x1 of nt, t is equals to 1 over fs, and fs is 100, is equals to, all we need to do is to replace xt by xnt. So we just write the equation down, and each t that we encounter, we put nt. That's all. Now, what is n? Just n. What is t? T is 1 over 100. So this is it. So this is x1 and t. But actually, this representation is the same as x1n, because x1 and t, later on you realize there's no t inside the equation. T will disappear. 40 divided by 100 is 2 over 5 pi n. 3 over 5 pi n. And that's it. So that is simply, did I make a mistake? No. Yep. So this is the first equation. So this is trivial for your 2 marks. So the x2 is a little bit more interesting. So the only difference is 40 pi, and this time t is equals to 1 over fs. In the second case is 1 over 40 and n over 40. So this is the slightly more interesting case. 60 pi n over 40. Now when we reduce this, 2 sine pi n plus 3 cosine. Now here's the interesting, 60 over 40 is 1.5 pi n. Okay. So we have the 2 equations now. Now you must comment. And the comment is this. This guy is an under representation of the original signal. So this sinusoid is faster than this sinusoid on the top. 60 pi is rotating faster than 40 pi. However, when we see 1.5 pi n, actually it is rotating at minus 0.5 pi. So it appears this is an alias signal. It appears to be rotating slower than this guy. Okay, so that is the comment. All right, any questions so far? So this is 6 marks. That's it. So we have 2 marks here. You have 2 marks here for x1. You have 2 marks here for x2, and you have 2 marks here for the aliasing comment. All right, I'll pause now. Okay, so we have another example. And in this example, it is November, December 2014. So let me pick up the questions now. And this is again question 1A. Okay, so this question is x a of t is equals to 3 sine 100 pi t. So this is an analog signal, and this is sampled. Fs is 300. Okay, so it is sampled. So the question itself says sampled at 300 samples per second. That's all. And find xn, the discrete time representation, and determine if xn is periodic, and if so, find n. That's it. So these questions are very similar to the tutorial questions. Okay, let's try. X. So again, I'm just right. So what is t? T equals 1 over fs. What is fs? 1 over 300. That's it. So we are substituting. I mean, you are thinking that we are substituting like this, and that's not too far wrong actually. Okay, you think like this, and then you get 3 sine 100 pi. For every t, we substitute as n over 300. That's it. 3 sine pi over 3n. So this is the answer. So it's very easy. And now, of course, we want to find xn plus big N equals to xn. When does this happen? It is when 3 sine pi over 3 small n plus big N will be equals to 3 sine pi over 3n plus 2 pi k. That's it. So these two equations allow us to solve for n. What is k? Number of cycles. Okay, so in some cases, we need to jump a few cycles before we get it periodic. All right. Now, so all we are doing is we need to expand these guys, and we have pi 3n plus pi 3 big N equals to pi 3n plus 2 pi k, and then of course this goes off, pi goes away, and then we have n equals to 3 times 2k. And here we get 6k, and we let k equals to 1, because by k must be an integer. By letting k equals to 1, we get the fundamental period. Fundamental period is 6. Number of samples is equals to 6. That's the answer. So n equals to 6 is the answer. And then you get, so this simple question is a giveaway again. It is 8 marks. All right, so you realize that there are always a lot of some of these questions that are relatively easy. Okay, I'll pause now. Okay, in this third example, of the question, it happens in April, May 2016. Okay, let me get the question first. April, May 2016. And the question is in 1A. The question is x of t is equals to cosine 16 pi t plus pi over 3. All right. Now, so the question is different from previous. Here it says find. Find what? Find fs in the range of 25 to 39 hertz. That means I'm asking you, decide which sampling frequency. Is it 25, 26, 27, so on up to 39, such that xn, the discrete version of xt, is periodic. Okay, so maybe you'll be confused with the question, but it's a 6 marks question. So let's attempt it anyway. All right, so we always start with the same idea. We'll just say t is equals to 1 over fs. So we have no idea what t is, what fs is now, because this is what it must be between 25 to 39. All right, and then we just write x of nt, and we are just replacing equals to x of n over fs, right? So that's the same idea. Okay, t is 1 over fs, so it's n over fs. Then this whole thing, we take it as, we put this n over fs as the little t in the equations above, n over fs. So this is the discrete time representation. Cosine 16 over fs pi n. So this is what we typically see. And now we want to make this periodic. Therefore, when does xn plus n equals to x of n? Well, so we'll just do cosine 16 fs pi small n plus big N. Again, when is it equals to cosine 16 over fs pi n? I forgot. Plus pi over 3. Plus pi over 3 plus 2 pi k. Again, you realize that the offset is, this guy doesn't matter because he's a constant. The offset is a constant, so we don't care. All right. So all we are interested in is when does this thing happen, which is 16 over fs pi n plus 16 over fs pi big N equals to 16 over fs pi small n plus 2 pi k. And again, this is exactly the same as before. This guy swipes out. The only thing that is exciting is these two equation here, these two left and right hand side here. And now we can solve for big. So now here we have a problem. We have a big N and we have a fs. Okay. So never mind. Let's push on. So we say big N equals to the pi is also gone, right? Pi cancels. Okay, so now is 2k divided by 16 times fs. So remember n, so this is the trick, n must be integer. K must be integer. K must be integer. So what do you do? Right? So if k is integer, 2 over 16 is 1 over 8. That's not good enough, right? So you choose different K, you choose different FS. But remember the FS must be in the range of how many? 25 to 39. So later on, I mean, if you use this limit, use this constraint, and then you realize that the only thing that we can get is K is 1 and F is 32. So let's try 2 times 1 times 32 divided by 16 is equals to how many? 4. So then we can choose n equals to 4. That means this guy is periodic when we sample at 32. All right, so this question is a little bit more interesting. It's slightly different from previous example, right? Previous example is always from xt give to xn. Now is the unknown is fs. Okay, do you have any questions? I'll pause now. Right, so now I have another example. This example is April, May 2017. Question 1a again. So you see question 1a is always the very, that kind of question. Okay, so this question is a systems kind of question now. So the question is, given an LTI, linear time invariant system, and this LTI system, the impulse response Hn equals to, and then I give you this. So it means that continuously it'll be 0 value, okay, to the n. And then I will need to give you n is equals to 0, 1, 2. So it means that this time is n equals to 0. Okay, so if you want to do graphically, it looks like this. I send an impulse. This is the system. This is the output. Time 0. Before that, nothing. Okay, this is 1, minus 2, minus 3, and 0, 0, n. This will be h of n. Actually, I should say this is y of n. The output is equals to h of n. So in English, what we are saying is input equals to impulse. Input is what? X of n is the input. So this is the impulse. The impulse is x, sorry, the input is the impulse. The output, this is the output, is the impulse response. So h of n is called the impulse response. So these are all the technical names for all these things. All right, so the input, so let's recap what we know. The impulse response have two types of response. One is called an infinite impulse response, means it'll go on forever. Here, you know, after the n equals to 0, 1, 2, in fact, at time 3, time 4, time index 5, it dies. So the impulse response in this example is finite. So here is also called a finite impulse response system. Means when I send an impulse, the impulse response doesn't go on forever. It dies. Okay, that's it. All right, the question is, so this is the beginning part of the question. And then the question in 1AI is show. All right, that the above system is stable. Show that the above station is stable. By, the hint is by proving the absolute summability. Actually, I shouldn't be giving you this hint. Summability of impulse response. So if you look at your lecture notes, you realize that a system is stable. System is stable if So this is the condition. So the hint is telling you that when the impulse response, this is the impulse response, and this is the absolute value, and this is for all the impulse response. So when the impulse response is absolutely summable, the system is stable. All right, let us see the what is this value. So it is summation n equals to negative infinity infinity h of n. But in this case, since we only have n equals to 0, 1, 2 that is non-zero, so this is nothing but 1 plus minus 2 plus minus 3. And that's it, because the rest of the thing is 0 on the right hand side and 0 on the left hand side. Okay, so it is nothing but 1 plus 2 plus 3, and the answer is 6. So the impulse response, the absolute value of the impulse response sum is equals to 6. 6 is less than infinity. Therefore, the system is stable. Finish. Okay, so this is how we prove. I shouldn't be giving you, I should just say show that the above system is stable, and then you should be telling me the system can be shown to be stable, or an LTI system can be shown to be stable if the impulse response is absolutely stumbleable. You give me this equation, then you say that the value of this equation comes out to be 6, and since 6 is less than infinity, therefore the system is absolutely summable. Okay, so I'll pause now. This part of the question is 6 marks. So another part of the question, we have 1 AII. In this part of the question, it says, what is the maximum value? What is the maximum value at the output of the system if input is bounded by real value 2? So what does it mean? It means the system is above. This system, remember, is that Hn that we have just mentioned, this guy on top, the Hn. And we have, and now the question says, anything we send, yeah, anything we send, some positive value, some negative value, some positive value, some positive value, but it is bounded. -2 here, 0 here, +2. Any value we send across all time is bounded by +2 and -2. The question is, what is the maximum value that we can ever obtain in the output? So it's a bit interesting. Then you say, okay, to understand, to answer this question, what is Yn? Okay, so the answer, of course, is Yn is equals to Xn convolved with H of n. And the right, let's say the convolution equation, which is summation of xk, h of n minus k, from k equals to negative infinity to infinity. Or you can also write it this way, h of k, x of n minus k, k equals to negative infinity to infinity. Okay. All right. So let us write in this way, because this is the slightly easier way to understand. Okay, so this is the convolution equation. It describes the output at time n with respect to the convolution of the impulse response and all the samples. Well, how do you see all the samples? See, k equals to negative infinity to k equals to positive infinity. But you realize that our hk is very interesting. Remember, what is our impulse response again? Our impulse response look like this: 0, 1, 2, followed by all the zeros. So this is 1, this is minus 2. This is minus 3. So this is h of n. Well, if you say, where's h of k? If you write this as h of k, then this is k, right? No difference. You get the number right? 1 minus 2 minus 3. So this is times 0, times 1, times 2, times 3, times 4, previously. So so this is our impulse response. So you realize that, hey, the only thing interesting about our impulse response is all here. These 3 points. These 3 points means at k equals to 0, 1, 2. No other places. So this little convolution equation reduces for this example to be nothing but h of 0, x of n minus k, plus h of 1, x of n minus k here is 0, 1 plus h of 2, x of n minus 2. Because the rest is all 0. Previously, the rest is all 0. Right? So since this is only this interesting guy, then let's write it down. Y of n is equals to h of 0. What is h of 0? H of 0 is 1. Okay, we leave this alone first. Plus h of 1 is minus 2. Then this guy. Plus minus 3, this guy. So what is these boxes? This is x of n. This guy is x of n minus 1. This guy is x of n minus 2. Now, if I say you can arbitrarily choose these values, but it must be bounded by 2, what would you choose? So the maximum, you want to choose this value such that output is maximum, right? So maybe by now you have figured out, hey, I use 2 multiplied by 1. I use minus 2 multiplied by, right? And then of course the answer is, then it is trivial. The answer is nothing but 2 plus 4 plus 6. And the answer is 12. Okay, so this is the answer for this question. So this question, you need to understand convolution equations, and then you need to, of course, once you understand the convolution equations, you understand that most of the values of h are 0, then it is very easy to solve. And then this is nothing but picking the largest value, but the correct sign. If you cannot pick up the correct sign, of course, you're finished. Okay, and then this guy is how many marks? 4 marks. So actually, I find that this question is more difficult than the first one. So, but sometimes it's not the difficulty of the question, right? All right. Now I'll pause. So we have done half an hour, okay?